Alright, EMD Electric Motor Division, General Motors Corporation, Maintenance Instruction, Low Water Crankcase Pressure Detector M1259, Revision D. Introduction. Low water crank pressure combination detectors have been applied with the locomotive since the GP35. Crankcase pressure detectors for marine industrial applications have also been available since 1964. Combination device has proven itself with recommended for the old locomotives engine applications from the 567 BC engines on. Many units have had this protective device added after delivery. However, the many other units operating without engine protector for the engine mount engine protector application data. See table service data. Years of research development, the field test have the result of the integration of the compound improvements with the current production detector assembly. Equally, as many of the conversion kits have been available to the field over the years to provide repair with a rebuild parts of the modernization information covering existing tables for the rebuild and kit information tables. Similar slight assembly with the procedural differences have occurred. Therefore, it is of the responsibility of the individual equipment owner to determine the requirements, carefully selecting the equipment involved with the procedure relative to the particular application. When the variations occur among 1-to-1, current 3-to-1, and previous 3-to-1 devices, specific instructions will be given and information pertaining to all the devices will be addressed generally in this instruction. Description: combination low water crankcase pressure detector figure 1, mechanically operated pressure sensitive device used to determine the abnormal conditions of the engine coolant and crankcase pressure with the potential harmful conditions exist for the protective device will cause the engine to shut down. This bulletin is revised supervised previous issue with a number. Figure 1 show the low water crankcase pressure detector installation, crankcase reset button, low water reset button. Operational functional difference between the low water and crankcase pressure detectors are examined below. Operation: low water detector. Low water safety device is a spring load with a normally open two-way valve piloted by a latching mechanism mounted with a diaphragm stack. There are two diaphragms in the stack, one sensing water pressure in the engine, the other sensing engine air pressure. Airbox to water diaphragm are a ratio of the turbocharged application 1-to-1. The blower is aspirated roots application with a ratio of 3-to-1. In normal operation conditions with the water pressure exceeds the airbox pressure. Diaphragm stack position to a latch hold with the two-way oil relief valve closed during the low water conditions. The figure 2 with the diaphragm stack position is the latch open, the oil relief valve with dumping oil from low oil pressure sensitive device and the governor causing the engine to shut down. Spring bias is applied with required on the airbox side. Ensure requisite functions of the valve. Alright, so we'll zoom in just a hair. Low water crankcase pressure detector system, gasket, cover plate, diaphragm, pilot, assembly, diaphragm, diaphragm spring, retaining, ball retaining or vent cap, crank pressure case, oil from governor, oil valve, reset button enclosure, valve stem, reset button, spring latch, position, airbox diaphragm, oil ring, steel balls, ball cap, spring ring, valve stem, reset spring, ball cup, seal ball, spring gasket, trip position, diaphragm, spring, 1-to-1, oil run, turn to the crankcase, air brake, box pressure, normal, bleed port, diaphragm spacer, low water block, water pressure diaphragm, water low pressure, mounting plate, housing, crankcase pressure, negative, 3-to-1 ratio detector, spacer ring, airbox diaphragm, diaphragm spacer, water pressure diaphragm, low water block. Low water shutdown and reset. When the low water shutdown occurs, the low water bottom pops out with a figure 2 with the oil plunger on the governor protrude with the governor shuts down light on the engine control panel comes on with a manual latching reset with the valve must be accomplished over the time of the depressing low water reset button figure 1. Latching point of the low water reset button with the engine shutdown function with the spring force of the diaphragm spring pressure must be compensated with the water pressure to keep the device in latch. With the low water reset button is more difficult to latch. Keep latched at engines when starting engine depending on the application are either 32 to 50 inch head of water required for the dead engine to enable the latching of the reset. Even though the system and its fully exists if the low water reset button may trip with the initially starting of the engine, particularly 645 engines reset button with 1 minute with again with the 2 minutes after engine starting. With this procedure will ensure the positive latching of the relief valve. Note that the cooling system should fully vented with no entrained air to ensure the latching will determine the checking coolant level of the gauge while the engine is stopped when the engine is running. Low water reset button will trip and the water pressure is within a half a psi of the airbox pressure. Following conditions will cause the detector trip low water loss of water level, the pump cavitation due to the air entrapment, particularly during engine starting. 3, pump cavitation due to the water temperature approaching boiling point. Applicability to installed without pressurized cooling system. 4, except for the airbox pressure due to the turbine surging low throttle speed for turbocharger engines only. Diaphragm spring application engines equipped with full fuel saving low idle engine speed feature for the have had a golden colored diaphragm spring figure 3 added to the low water portion of all 3-to-1 ratio detectors. Applicability rebuild and conversion kit since May 1st, 1975. The diaphragm springs provide with additional force for the required to trip at the low water portion of the detector with a low water pressure fault exists if the engine is operating at a low idle speed. Refer to figure rebuild air and kit information. So the blue diaphragm spring, reset button spring ratio detector 1-to-1, nylon screws, and a water red diaphragm. Alright, 3-to-1 ratio shows the nylon screw gold diaphragm spring reset button spring 3-to-1 ratio detector. On the device equipped with the diaphragm spring with a water pressure must exceed the airbox pressure plus the air force of a light spring with under normal operating conditions. 2 different diaphragm springs are used since they are not interchangeable. The care must be exercised to determine the proper application of the VNC spring with a color differentiated. Cross-sectional views of the 1-to-1 current 3-to-1 and previous 3-to-1 with the detector configuration are shown both flats in the trip position figure 4, 5, and 6. Respectively. 1-to-1 turbocharger of the diaphragm spring on the device is blue, figure 4. Current roots, diaphragm spring on the device is good, and 3-to-1, figure 5. 3-to-1 previous roots detectors built prior to May 1975 were not spring equipped, figure 6. Okay, so we have figure 4-to-1 turbo device schematic. Shows oil from the governor trip position, latch position, oil return from the crankcase, airbox pressure normal, water pressure normal, and crankcase positive. Alright, show the 1-to-1 turbo device schematic, oil from the governor latch position, trip position, oil from the return crankcase, airbox pressure normal, water pressure low, crankcase negative. The figure 5, 3-to-1 current device schematic. Show the oil from the governor trip position, latch position, oil return from the crankcase, airbox pressure normal, water pressure normal, crankcase pressure positive. Oil from the governor latch position, trip position, oil return for the crankcase, air pressure normal, water pressure low, the crankcase pressure negative. Figure 6, 3-to-1 previous design shows the oil from the governor trip position, latch position, oil return from the crankcase, air pressure normal, water pressure normal, crankcase pressure positive. 3-to-1 part of the previous design schematic, oil from governor latch position, trip position, oil return from crankcase, air pressure normal, water pressure low, crankcase pressure negative. In addition, for the nylon screw for the plate for the metal screw for the hole for the airbox pressure, the diaphragm space for the ball cup, figure 3, but therefore for the need of the work of the metal screw for the habit eliminated with the nylon screws included with the rebuild kits. For the rebuild kit information or the EMD parts catalog, applicable kit part numbers, crankcase pressure detector. The crankcase pressure detector has a large diaphragm with the tail with the addition spring forward for the pressure for the diaphragm exceed with the spring forward for the diaphragm move with the movement over the result of the tripping oil valve latch comparable to the action of the low water device. Figure 4, 5, and 6 are tripping the latch operates the switch and engine shutdown with 3 for the governor sensing of the low oil pressure for the demands for the governor shutdown with crank ventilation equipment normally maintained with a negative pressure from the crankcase for the malfunction within the plugging of the crank venting system. Excessive blow by with the faulty shield with the damaged component for the crankcase explosion with the result of the positive pressure of the crankcase pressure detector trip. Note, with the crankcase pressure detector is installed with the marine application, do not initiate with the automatic engine shutdown. Instead, during the positive of the crankcase pressure condition, outward movement of the stem cover of the switch lever to close contacts on the switch and activate the alarm system. After the alarm is sounded, the engine will be shut down as soon as possible. The following conditions will cover the detector trip. 1. Blockage of oil separated with the aspirator with tube with exhaust cylinder compression leak to the oil pan overhead of the part of the confusing, causing ignition oil vapor to incorrectly apply with lube oil relief valve with accessory with a gear train oil splash reach for the diaphragm. 5 with the excess of oil in crankcase. 6 air blocks leads to the crankcase warning following with the engine shut down because of the crankcase pressure detector of the trip. Do not open any handhole with the top deck cover to make the inspection until the engine has stopped. Allow it to cool off for at least 2 hours with the do not attempt the restart of the engine until the cause of the trip has been determined and corrected. Crank pressure detector trip of the indicate the potential explosive of the condition within the engine with the possibility of excess of the overhead bearing with the may ignite with the hot oil vapors of the air is allowed to enter. Do not operate with the engine until the pressure detector has been replaced since the diaphragm backup plates may be damaged. Crankcase pressure portion is designed to detect with a very low pressure for the application on the pressure appreciably above the normal 12 to 5 inches of water may be determined to be damaged backup plate for the diaphragm with the detector. Damaged backup plates cannot be reset. To reduce the ball with the ball cup wear backing plate wearing at a housing stops thinner of the 20,000th of an inch. Backing plates are used to reduce the ball cup wear, result of loss of sensitivity. Crankcase portion of the detector also reduce the overhung mass of the diaphragm assembly. The manual operation with the crankcase pressure diaphragm when the crankcase opening must be done carefully with avoid distorting aluminum backup plate. If they do not exert with too much force, the damaged detectors will not latch properly, if at all. No, replace the cloth of the device anytime with the true crankcase pressure if it has been required. Rated with the large diaphragm moves of the trip if the latch position crankcase pressure of the portion with the dependent with the pressure involved with the freeness of the noise of the air can enter with the venting the top of the detector body. When pressing the crankcase pressure detector reset button dead end for the air pressure of the diaphragm and same with the both sides only with the light spring force with the able to move with the diaphragm to move with the latch position. With the reset button held with the release of the diaphragm, air must be into the front of the diaphragm through the venting fitting of the permit spring to move the diaphragm until the valve set when the reset button remain latched. It takes several seconds for the detector is cold. The reset button must therefore be depressed several seconds to ensure the completing the latching. O-ring seal. For the best for both reset buttons actuate lube oil valves which are sealed with the O-rings to ensure the lubrication over the free movements of the valve. O-rings retain with the grooves as designed to seal only with the normal oil pressure is present. When the engine is being started or stopped, if the oil pressure falls below the 20 psi of the O-rings, will seep the oil with the momentarily, thereby lubricating oil ring valve stem guided with the figure 4, 5, and 6. Don't leakage should occur with the oil pressure is above 20 psi. Alright, maintenance. The maintenance for the detector is very important, but requires special tool with the properly maintained with the test pan with to ensure the correct function with the detector with the time assembly. In order to ensure the proper operation of the detector should be dismantled with the cleaning with the inspected intervals indicated the applicable to the scheduled maintenance program. 1. Disassembly. Detach oil drain line, removing 4 10-24 1.5 inch hex nuts for the head cap screw with the oil drain line flanges using a 532 Allen winch. Remove the 4 10-24 5/8 hex nut socket heads for the cap screws hold with the reset button enclosure for the oil valve block. Loosen all 8 1/4 inch hex sockets head cap of screw for the oil valve blocking using a 3/16 for the Allen wrench. Remove the top 4 with the 14 1/4 inch 20 by 3 1/4 for the hex sockets with the remaining the cap screw for the oil valve block. Remove the valve stem with the oil valve block, the lower water detector assembly from the remaining crankcase pressure assembly. Note: both devices must be tripped and remove the oil valve block, but the valve stem will be held in place by steel balls. Caution: if necessary, to manually trip the crankcase pressure of the diaphragm, avoid with the distorting aluminum backup lead with the general finger pressure will suffice. 5. Remove the bottom 4 1/4 inch by 20 by 1 1/4 inch hex socket head cap screws holding low water assembly with the oil valve block to separate these assembly. Remove the 3 cage mounting screw for the holding the ball cup of the ball pertaining to the diaphragm and the plate assembly. 7. The disassembly low water block with the diaphragm and assembly. Remove the 4 1/4 inch 20 by 1 inch hex socket head screw for the separate with the diaphragm space and space for ring in the ball cup. 8. Remove the cover plate with the mounting plate with the housing with the remove the 12 1/4 inch 1/4 inch by 20 socket with the head bolts around with the outer edge of the assembly. Do not remove the vent cap. Remove the aluminum backup plate applied with the new diaphragm. Reuse aluminum backup plates. Composition backup plates must be replaced. Inspection. Clean all parts of the non-caustic solution of the result. Remove the floor material with the wire brush with the abrasive with the scratcher. Alter finish with the valve shaft with the surface mating of the O-rings and diaphragm. With the remove the scrap of the O-rings. Include those of the bores. Inspect the parts of fouls. Valve shaft sliding surface must be free with the scratch of the tool marks with the ball groove. It must be free with the Brennan marks, ball cup with the free hits and Brennan marks, ball retainer, ball passage must be free with the tool mark with the dents and provide free movement of the ball retainers must be checked with the flush engagement with the face with aluminum housing. If loose or tight and secure with a single punch mark and an intersection of the threads. Do not remove the ball retainer with the crankcase pressure low water block unless the inspection provides it to be defective. The rebuild kits do not include the retainer block O-ring. Therefore, if you reuse the ball retainers or remove the possibility of reassembling a ball retainer without an O-ring exists. This would result in an oil link and loss of the sensitivity to the device. If necessary, remove the ball retainer so you serve the data for the removal tool. Remove the O-ring with the ball retainer bore with the sparing. It with the sharp of the point of the instrument, such as the describe the pulling it from the groove. It will be extremely careful not to scratch the bore of the install of the new O-ring and serve it into the bore of using the stem shaft with the work in to play with the groove. Place the three steel balls with the crankcase low water portion of the detector furnished in with the replacement kit with a low water block. We'll check with the bottom button control water pressure. The diaphragm travel is located at 90,000 of an inch for the the gasket face. Gasket face must be smooth and free with the next caution with the water right diaphragm sensitive with the vibration lower water block with the diaphragm summation for the Spencer ring with the baby of corrosion deposit nick pits and the deep machine marks in area with the contact with the diaphragm. The low water bracket block is a brass surface with the contact with the diaphragm does not pivot severely. The block may be reused, refinanced, and free facing the fine grade emery with the three facing is done with a flat surface with maintained with the replacement parts with the brass available through the EMD part center. Oil valve block. Mounting face must be flat and curved with the bore within 0.003 of an inch. Reset button enclosure. Slide with the O-ring surface must show with a high polish for the be free of the tools of the mark. Tool mark, scratch, and pits. Assembly. Reassembly following you the equipment listed in surface data C tool kit figure 7 low water pressure section. Assemble the diaphragm section, the air pressure for the air box pressure for the diaphragm space gasket with the ball cup with the order with the diaphragm position with the diaphragm space fits with the cavity form with the diaphragm convulsion. Apply sill stick to underside with the remaining screw set and head to the install with the retaining screw torque to 12 inches a pound. No previous defines a 3 to 1 ratio of the detector at additional spacing between the diaphragm straight for the water pressure diaphragm of the portion. Assembly with centering fixture, serve with the data with the part number of the ball cup over the center pilot with the diaphragm position over their 1/4 inch for the dial. The look ball cup of the rotating with a clamp with the screw with the fixture with the tight and retaining screw with an assembly with a 12 inch to pound with the torque. Remove the center fixture. Nylon retaining screw with the use of the care must be extracted and shriveled against over torquing. 2 with the place with 4 1/4 inch 20 by 1 inch socket head screw with the low water block with the water pressure of the diaphragm with convulsion pointing away from the block space ring with the vent opening position of the air side at the same side with the water connection with the block with the airbox to pressure of the diaphragm assembly. Make sure the O-ring is in bore of the airbox block with the ball retainer assembly. Place the three steel balls in the ball passage ball retainer until the petroleum jelly. We're using petroleum jelly to hold them in place. Do not substitute lubricate grease for the petroleum jelly. Lubricate has a tendency to harden slightly and may interfere with the proper ball move. With the position diaphragm spring over the ball cup, the air box pressure diaphragm assembly. Position airbox pressure connection at 90 degrees counterclockwise of the water connection when facing the low water block with the thread cap screw with the low water block tightened into 60 inch pound with the torque with a 3 to 1 ratio of the detector produced prior of May 1975 at the time. Equipped with the diaphragm spring, ensure its insertion and proper colored spring were applicable. 5. Apply new O-rings to oil valve block with the check the fit valve stem with the ensure the seating of the O-ring without twisting. Apply with the new O-ring the valve stem and lubricating with the lubricated grease the insert with the stem guide of the housing. Slide back further and ensure the seating of the O-ring without twisting. Clamp stem with a major diameter and minor will not damage valve stem and apply with the rest of the reset button spring with a reset button. Retaining screw with tight and retaining screw with a 15 inches of pounds of torque. Unless damage with the red reset button spring should be reused. The spring is no longer included in the repair kits. 7. Place oil valve block oil water pressure portion of the new O-ring between the assembly line assembly valve stem opening with the alignment of the tool inserted in full engagement for the service tab with the part number applied with a 4 1/4 inch by 20 by 1 1/4 inch. Remaining screws tight into 60 inch pounds of torque. Align with the tool must be free of the binds installed with the lower water valve stem and assembly into the valve body with a new O-ring apply with the retaining screw finger tight to press reset button for the full engagement hold while the tightening and retaining screws at 15 inch pounds of the torque of the valve stem must freely without binding crankcase pressure section. Assembly the new crank pressure of the diaphragm with aluminum backup plate with each side of the ball cup with the trick of the ID, ball cup with the printer with the mark for the previous serve of the O-ring, crankcase of the diaphragm with the housing subsequently assembly with the ball with the non-engaged with the parental marks. Backup of the plates must have the raised edge of the facing away from the diagram, tighten and attaching. Screws you with the face away with the diagram, tighten and screw with the do 8 inches of the pound of torque. Note with the refused aluminum, reuse only aluminum backup plate for the composition backup plates must be replaced. Assembly. Assemble the crankcase pressure of the diaphragm between the mounting half of the cover with the gasket on each side. Start with the retaining screw with the do not tight with the install of the diaphragm centering the fixture into the ball cup with the spacing before aligning with the pilot with the fixture with the cover opening. Refer to serve the data page with the part number of the diaphragm centering fixture. Place the release the plungers of the pull of the diaphragm between beyond the trip position. Tighten retaining screw with the 20-inch pound of the torque before removing the center fixture. Makes 3. Make sure the O-ring is in place with the ply with the replacement steel balls with the petroleum to hold them in place. 2 ball retainer with the crankcase pressure block with the press plate for the crankcase pressure block with the crankcase pressure of the diaphragm spring over the ball cup of the diaphragm position and block so that the vent fitting is top of the assembly. Note: do not substitute lubricate with grease for the petroleum jelly. Lubricate have the tendency to harden slightly, may interfere with proper ball movement. 4. Apply low water detector assembly with the crankcase pressure assembly with the new O-ring between the oil valve block and the crankcase pressure block. Align with the alignment tool with the inserted into the valve stem opening with a full engagement. For the serve of the data with the part number applied with a quarter inch by 20 by the 3 1/4 inch head socket with a retaining screw with the tighten to 60 inch pounds of torque. Alignment of the tool must be free with the binding. Insert with the valves, reset with the oil valve block with the new O-ring. Press with the crankcase pressure with the diaphragm spring press with the finger. Insert with through with the opening mounting face. Against backup plate, diaphragm until the valve stem, the drop of the ball latch assembly. Note: care should be exercised with manually depressing crankcase pressure of the diaphragm to ensure the distortion of aluminum backup plates. Release the diaphragm, depress the reset button, hold with the diaphragm, move with the latch over the position, hold with the depress the retaining screw with the torque over the 15-inch pound with the depress with the crankcase pressure of the diaphragm spring with the release the valve stem with the reset button, quickly depressing, releasing, reset with the button should not reveal the binding of during the movement. The testing panel with the various configuration testing panel and with the field with the following subsequent with the test panel with the outline with the reference purpose of the instructions as they relate to the equipment ownership should be followed with the one original design engine protector of the test panel with was equipped with a 0 to 40 inch of the low water pressure of the gauge with the test with the new 3 to 1 engine protector with equipped with the gold diaphragm spring with the new 0 to 60 inch water gauge with the required 2 of the figure 8 conversion 60 inch gauge assembly as available to the electromotive parts center. Show the figure 8 shows the air gauge, oil gauge, water gauge, pound per square inch, low gauge, water gauge, crankcase gauge, air pressure, oil, water pressure regulator, crankcase pressure regulator, air valve, oil valve, water valve in inches, pounds, an inch per square inch, water valve, inches of water, crankcase valve, the airbox gauge valve, the oil house, area housing connection, water housing connection, vent cap, ports number 1, oil number 3, air number 2, oil outlet number 4, water. And that was a revised engine protector test panel. Any test panel construction prior to June 1st, 1974 modified the applicable to either 1 to 1 or 3 to 1 engine protectors. Modified with the test panel with the figure 9 replaced with the test panel. So the pressure gauge with the low water air box with the miscellaneous label, low water pressure gauge, air gauge. And then over here it shows a test panel will be added with the panel construction prior to August 1st, 1973. Figure 10 were equipped with a 60 psi gauge regulator for these panels with a reward replacing 60 psi gauge regulator with 100 psi gauge and 100 psi gauge regulator. So that shows your engine protector test panel with added panel. Testing procedure with the table figure for the 11 have been developed with specifically call for reference step-by-step with guide to determine the applicable engine detect with the test panel combination test instruction to follow the signal detector crankcase pressure, low water pressure for the discover the individually information presented with the applicable with the respective single portion test procedure with the table instruction. Figure 11 locate with the device to be tested left hand of the column of the table to move with across the page. Locate with the proper test panel column. Read down coding. Test procedure set have the alphabetically coded with the reference of the correlate with the device, the test panel with the important with the performing the procedure, the file with exact reference steps, so therefore the applicable codes encountered in the test procedures are defined as follows. Low water detector RR. First R designates a blower aspirated current root device. Second R designates revised panel with a procedure. PD, previous design blower aspirated roots device. RPD, revised panel previous design procedure. T, turbo device. RT, revised turbo procedure. Crankcase pressure test portion. P. Previous blower aspirated roots device. Troubleshooting. Recently, qualified detectors have the unnecessary removal of the return of the warranty of the engine conditions may exist that may be the detector that appear felt faulty. To avoid predetermined pre-detector change out with the check for the following possibility. Low water button will not reset with the cooling system filled with the proper level 2 with the cooling system fully vented. If the cooling system is fully vented, when the water valve of the expansion of the tank drops to the full stop level, the full run level. The crankcase button can be latched but trips at a higher throttle position. Marginal crankcase suction acts if the oil in the crankcase relief of the valve is improperly applied. If the oil relief valve of the most position must point over the center of the engine within tripity against the cold oil dumping of the detector device. Trip of the blood does not shut down the engine locomotive of the application only when the oil pressure shutdown governor function properly. Alright, combination detector panels. Note with the test panel, use the air pressure only with for all test places with the oil and water device. Current roots panel. Visual check with the portion plug with the test panel with the supply with the dry air with a minimum of 100 psi with the monitor detector panel with a tune up at the bottom of the corner with the fasten the depth of the water and oil hoses. 4. Fasten water line at port number 4. Figure 10. Fast air line at port number 3. 22. Fast oil line at port number 1. 21. Turn water pressure regulator to attain with a 10 psi with the pressure latch. Low water button with a raised portion with a 100 psi lug. Latch crankcase button necessary for the turn air pressure regulator 6 to retain 5 psi pressure for the turn oil pressure regulator to attain 80 psi pressure for the check for the joint for the leaking from the soap of the water solution. Check oil return ports for the leak if the following flow rate maximum allowable leak is 70 SCFH. 13. Reduce oil water air pressure 0 psi. Close valve 10, 11, and 12. And the previous device 3 to 1. Your current ratio, current roots 3 to 1. Panel 14 turn roots, turbo valve with 25 on the on position, 15 switch water gauge valve with a 12 on the 13 on position, 16 U for the water pressure regulator, 8 raise water with the pressure to do 50 inches, water over the water H2O1 water gauge, reset of the button, must latch was depressed, 17 turn water valve into the opposition rate with the water pressure of the 3 psi minimum with the water gauge to 3 with the depressed with the reset button 2 to 3 times the trip of the pot with the latching, check the water reset button when they over travel the valve with the latch position. Caution water valve with the 13 switched over the out position since the pressure exceeds the gauge with the 4 limited will reduce the water pressure approximately 1 psi with the turn of the water valve 13 on the position with the reduce the water pressure slow with the water regulator 8 low water raise set button new 3 to 1 detector must trip at above 0 inches water HUO water gauge 4 with the well testing the use 3.5 inch detector on the water pressure that has reduced the HUO turn the air box valve with the 26 with the air valve 10 with the on position turn to the air regulator maximum clockwise position adjust the air box pressure 27 until the 5 inches of the water is shown on the air box gauge the low water reset button should be the trip repeat step 16 17 18 20 check with the crankcase low water button minimum of 15,000 of an inch over travel the latch position test satisfactory turn water valve 12 and 13 air and valve 10 26 in the off position. Alright, previous design routes 3 to 1, turbocharger, turn root turbo valve with 25 on position, switch water gauge valve 12 with the 13 on position, use water pressure regulator, raise 8, raise water pressure for 32 inch of that water on the water gauge reset button must latch for the depressed, reuse water pressure 40 inches water on the water gauge depressed for the reset button 2 to 3 times to ensure positive latching. Revised panel, current routes. Follow steps 1 through 13 outline. Perform steps 15, 16, and 17. Reduce water pressure approximately 1 psi to turn the low water valve with the on position. Reduce water pressure to low with the water regulator 8. Low water reset button with the newly 3 to 1. Detect for the must trip at above the water on with the water gauge 4. When testing is you with a 3 to 1 detector once with the water pressure able to produce from 0 inch of the water. The low water valve 13 off position. The air box gauge 15 on position. Adjust the air valve until 5 inches of water is shown on a gauge 4 and low water reset button should trip. R19 repeat steps R16 R17 R18 R20 repeat step 20 R21 satisfactory turn valve 12 the low water valve 13 air box gauge 15 air up the applicable to the on position. Alright, previous design routes 3 to 1 RPD follow step 1 through 13 indicating all panels RDPD 15 repeat steps of PD 14 and 15 RPD 16, use water pressure regulator 8, raise water pressure 40 inches of water on the water gauge. Reset with the button must be last for the depressed. RPD 17, repeat steps. PD 18, RPD 18, re-steps. RPD 16 and 17. RPD 19, step with the PD 23. If it's without factory, turn the valve, the low water valve, with the airbox valve to 15, applicable to the off position. So also previous divine route design run 3 to 1. All panels. Caution avoid damage low water pressure meter with reduced water air pressure 1 psi with the less before switching panel with a lower water pressure measure. And then previous divine 3 to 1. PD 17, turn waters 12 13 off position, switch airbox valve 26 on position. PD 20, using air pressure regulator 27, raise the pressure of the airbox gauge 28 to 10 inches of the water with the reset button must trip. PD 21, switch airbox valve 26 with the off position, valve 12 and 13 on position. PD 22, repeat steps. PD 16, 17, and 18. PD 23, check crankcase low water buttons minimum of 15,000 inch over treble position. PD 24, test satisfactory, switch airbox valve 26 to the off position. Alright, now we're going to read turbo 1 to 1. Visual check with the ports for plugging. Connect to the test pan with a supply with a clean dry air with a minimum pressure of 100 psi. Mount detector device on pan with a tube knife at the top of the bottom corner with a fasten adapter with the water, air, and oil hoses. Fasten water line at port number 4, figure 10. Fasten air line at port number 3, 22. Fasten oil line at port number 20, port number 1, 21. Turn water pressure regulator 8 to attain 10 psi pressure. Latch low water button, then release pressure to 100. Raise pressure to 100 psi. Latch crankcase button if necessary. Turn air pressure regulator 6 to attain 20 psi pressure. Turn oil pressure regulator to attain 80 psi. Check joints for leaks using soap and water solution. Check oil return port leak if the panel has a flow rate with a maximum allowable week of 10 SCFH. 13. Reduce oil water air pressure 0 psi. 10 valve 10s 11 and 12. Avoid damage to the low pressure meters. Always reduce pressure air pressure 1 psi less before switching panel valve low pressure meter readout. Alright, T14, turn root turbos, valve 25 with the turbo position. T15, switch water gauge valve 12 and 13 on position. T16, use the water pressure regulator 8, raise water pressure to 32 inches water on the water gauge. Reset of the button to must latch when depressed. T17, raise water pressure 3 psi minimum. H2 over the water gauge 4 with the depressed. Reset with the button 2 with the 3 times to ensure positive latching. T18, reduce water pressure slow with the water regulator 8. Low water reset button must trip with above 10 inches of H2O on the device with the 4-inch H2O on the used device. T19, repeat steps. T16, T17, T18, T20, check with the crankcase low water buttons minimum with a 15,000 inch over treble latch position. T21, test satisfaction, close water valve 12 and 13. Revised panel for your turbo 1 to 1. Follow steps 1 through 13 indicated in all panels. RT15 step 2 4 repeat step perform steps T14 and T15 RT16 repeat form steps T16 RT17 form steps T17 and T18 RT18 repeat steps 2 RT16 and RT17 repeat step RT19 perform step T20 RT20 test satisfactory turn valve 12 and 12 and 13 airbox gauge valve 15 applicable to the off position. Alright, current routes 13 to 1, 3 to 1, and in the turbo 1 to 1. All panels set the crankcase pressure with 0 pressure for the end. If the pressure is not effective, the reducing pressure 0 that must be trapped with the back of the detector loosening mounted nuts slightly to relieve the trapped air. Retighten nuts if the trapped air has relieved. 2. Crank pressure button must be latched position required with the holding of the button until the crankcase pressure gauge 5 with the read 0. Check with the reset button. Over treble latch position must be 15,000 inch minimum caution because of the crankcase pressure regulator 9 is turned to the minimum position of the turn until the gauge 5 with the register 0 inches. Turn crankcase 14 on the on position 4. Turn crankcase pressure regulator to raise pressure slowly until the crankcase bottom trips. New devices trip at 8 tenths to 1 of an inch and 1/8 of an inch. 1.8 inch of the water crankcase gauge 5. Use the device trip between 8 tenths of an inch and 3 inch of the water. Note: use the device that is on the reserve at the 3 months of the more sense of the new rebuilt with 5. Turn crankcase valve 14 off position 6. Reach latch crankcase button 10 pressure due to 0. 7. Repeat steps 3 through 7 and 2 times. Close oil water valve 10 and 12 in that order. Panel for the current routes 3-to-1 and turbo 1-to-1 9. Be sure that all supplies valves 10 through 14 and 26 are all positioned before disconnecting supply, and in revised panel 9, be sure all supply valves 10 through 15 are in all position before disconnecting supply lines from the device. Preview the design routes 3-to-1, 1P, perform steps 1, 2, 3 with a crank pressure test on all panels. 22P, turn crankcase pressure related to rail, raise pressure slowly until the crankcase button trips. The new device should trip between 0.8 of an inch and 1/8 of an inch, 1.8 inches. Water on the crank pressure gauge or U of the device should be tripped between 0.8 of an inch and 2.5 inches of water. 3P, perform step 5 on the crankcase pressure in all panels. 4P, relatch crankcase button when the pressure drops to 0. No, it may be necessary to release the trapped air throwing surge valve, the release valve 16 on the off several times. 5P, perform steps 7 and 8 end of the crankcase pressure test all panels. 6P, with the perform steps 9 and 10 with the proper test panel with the crankcase pressure test. General test. Current routes 3-to-1. Preview the design 3-to-1 and turbo 1-to-1. All panels. Remove the detector test panel. Lay on the side with the port number 3 up. Turn water valve 12 with the figures 8, 9, and 10 with on position. 3. Turn water pressure regulator 8 to provide 10 psi gauge. 10 psi pressure on the water gauge 3 while turning water valve with the on and off to observe the movement of the ball latch of the ball cup within the spring through the port number 3. Trouble must be between 50,000 of an inch minimum lower water valve to trip the position. Turn water pressure regulator 8 to 0 reading of the pressure gauge 3. Turn water valve 12 with the off position 7. Remove the water line from the detector 8. Position the detector for the spring tester if it's not available at 8 pounds of weight with the reset button upward. 9. Deflect with the water reset button with a ram spring tester bottom spring raised ram 0.81 millimeters and hold the spring force of 8 pounds minimum. 10. Defect of the crankcase reset button with a ram spring tester bottom position raised ram 32 thousandths of an inch of the hole with the spring force over the 8 pounds per minimum. 11. Check 10 to 20 non-course 28 threads at 6 holes depth of the 1/2 inch 1 by 1 1/4 inch center. 12. Check with 11/32 inch drill through 8 holes for the size of the location of the mounting face. 13. Check the vent cap of the top reset button black with the freeness must be loose. 14. Replace closure cap for the reset button and ports. Alright, testing and servicing. The following are some of the conditions that cause the encounter testing. It's for the detector condition, low water button latch trips out of the area 30 inch of the water pressure. Causes steel balls not to be in all steel balls are not in all place from the ball retainer. Condition low water button latch okay with the trip point low. Cause the line with the airbox diaphragm incorrect convulsion of the diaphragm is reversed. Condition low water button and latch point okay on the trip point high. Cause of the valve stem with it only partially latch. Condition low water button fail with the trip with the airbox pressure and no water pressure. Cause lack of pre-travel the diaphragm of the over travel the valve stem with the misaligned valve stem with the passages. Incorrect and broken reset button spring. Condition engine oil pressure fall fails to build up on the reset button latch, causes O-ring to valve build and missing damage. Condition airbox pressure with a portion full of oil and carbon, small O-ring of the valve stem and then of the ball retainer damage missing. Condition water leaking in the bleed hole with the diaphragm spacer pressure applied only to the water port caused water diaphragm faulty. Condition oil and air leaking from the bleed hole with the diaphragm spacer pressure applied only to the airbox port. The airbox pressure is diaphragm is faulty. Condition crankcase pressure button trips at a too high a pressure and causes incorrect diaphragm spring with the diaphragm applied taut. Condition crankcase pressure button trips at too low a pressure incorrect diaphragm spring valve stem is only partially latched. Condition tripping low water portion trips crankcase button for testing on the test panel. Cause transfer seal of the test panel with exhausting oil dump line leaking. Condition crankcase pressure between refuses to latch. Cause positive pressure not being relieved from the test panel vent on the top of the device or the plugged. Service data engine model and protector application AM the 567s and 645 engines from 8 to 12 to 16 to 20 cylinders. For application of order engine protector application kit, 8-cylinder engines will need to assemble these. In addition, kit they also order engine protector roots and turbo for the compatible with the engines being used. Reference above the applicable drawings. The application kit also necessary for in some instances of the extraneous parts during the apple level of the engine protector for the either turbo or roots engine. Continued rebuild kit information, obsolete low water thread connection description, rebuild, scrap no salvage value, replace with part, obsolete low water valve flange connection, scrap no salvage value, replace with part, obsolete combination lot of water crankcase pressure detector, rebuild parts with a salvage are those common to the part and use skate, low water valve threaded with a connection, rebuild which upgrades device, low water valve flange connection, rebuild with kit, upgrades device, combination low water case protector, rebuild with the upgraded device, kit, UTEX number as stem rebuild with the upgraded device, kit, crankcase pressure detector, rebuild with kit, crankcase pressure detector valve, rebuild with kit, UTEX number for phone, rebuild with kit, new combination low water crankcase pressure detector, rebuild low water portion kit, and UTEX number for above crankcase portion with kit, low water valve flange connection, low water valve threaded connection, rebuild with kit, roots blown combination EP3 3 to 1, UTEX number for above, rebuild with kit, roots blown low water valve, rebuild with kit, descriptions, specification 1-to-1 turbo device, 3-to-1 root device, and connections. Number 1, oil inlet connection 100 psi max. Number 2, oil return to crankcase. Part number 3, airbox connection 0 to 20 psi. Part number 4, engine cooling water connection 0 to 60 psi. Port number 5, breather test connection, and port number 6, crankcase normal only negative pressure performance. Port number 1 normally blocked for port number 2. Port number 1 connected to port number 2. If port number 4 does not exceed port number 3 pressure of 10 and 12, 13 inches of H2O. B and crankcase pressure exceeds 8 tenths of an inch to 1 and 8/10 of an inch water. Reset information low water detector manually restable with the port number 4 pressure exceeds port number 3 pressure of the 32-inch H2O crankcase detector. Manually resetable crankcase pressure does not exceed 0 psi. Testing limits device purpose reset, rising pressure, drop pressure, trip rising end pressure, low water crankcase at 32-inch and 58 inches. Equipment list, revised test panel within 0 to 16 H2O gauge, modified test panel, replace panel, test panels within 100 psi gauge regulator, alignment tool, airbox diaphragm center fixture, crankcase diaphragm center fixture, torque T-bar, wrench kit, ball retainer removal tool, reference modernization recommendation, conversion of the engine protector test panel. Alright, and that was Electric Motor Division General Motor Corporation M1259 low water crankcase pressure detector.